Pablo and Enrique
will tell you about an issue topic which I feel is fascinating. Our work as cyber security experts is very much about it. Actually, this is extremely useful, and his presentation will be awesome. So you have the floor now. Well, first of all, we'll tell you about the applicability of artificial intelligence and its relationship with cybersecurity. We'll tell you about defensive and offensive techniques, and this is kind of that's kind of a didactic part of this presentation, and then we will share with you some real cases that we have developed for you to see how far we can get in terms of artificial intelligence applied to cybersecurity. So, well, sometimes we are kind of afraid, and they say, well, perhaps if artificial intelligence arrives, is introduced, perhaps we will be not be demanded as much. But if we bring together two profiles, people specializing in artificial intelligence and people specializing in cybersecurity, surely we can partner up very well and make up a very good team. So my name is Pablo González. I've been working in Telefónica for 6 years now. I have written a few books that are displayed outside. Feel free to buy them if you so wish. I also set up Hackers Club. It was an entrepreneur project. Then we also have with us Enrique. Enrique is specialized in artificial intelligence. He's got a degree in physics, master's course in astrophysics. I noticed he's here with us, discussing cybersecurity as well as AI. He worked in India for some time, then he went to Germany, and now he's back with us. We in Telefónica, those of us in Telefónica, we work at the Crazy Ideas department, meaning that it's a department where we are allowed to play around with technology, to experiment with technology, as well as with cybersecurity, artificial intelligence, and they give us free room for us to investigate and research. So we are at an innovation stage. For instance, we try out something, and well, we may write an article about it, and that will be it. That will be the end of it. But if we test something and we see that can be applied and can be improved a product or a service, we go ahead with it. And then we also work with patents, which is also good fun because our work is not monotonous at all. We all the time do different things. And now I will tell you more about it. Well, first of all, I will tell you about news. Please stay in the room. Do not leave the room. I will be brief here. Second, we will be talking about artificial intelligence applied to cybersecurity. Is it a marriage doomed to understand each other or not? Let us see what happens there. Then, let us also talk about techniques to develop attacks and defense, always based on IA algorithms. Then also we'll see what we have done with that up until now, and then applicability. There have been other presentations about phishing and the like, and then today we will be talking about fraud to CEO. Well, do all of you do that? Yes, nearly all of you do that. So someone go and say, well, if I send get that type of email, I will be in big trouble. So let us see how we can evolve that, how far we can get, so that you change your mindset. All right, we are starting now. You've all seen this video, I'm sure. It looks real, but it is not. A model was made with neural networks. But there was an artificial intelligence that have learned to move the mouth and as Obama, and then they just gave voice speech to it. The system, the model was trained. And then we have Jennifer Lawrence video. Can you hear that? Have you seen that before? It's good fun, isn't it? But this is for you to understand what happens with those type of attacks. If you don't know that he's Steve Buscemi, well, you wouldn't tell. The problem, the good thing, is that these face swapping techniques have also been taken over to the porn industry. Someone may go and say, well, this actress is in erotic video. Okay, we will stop that video. Okay, you can guess what comes after. And then we ask ourselves, how important is have fake news? Well, fake news are very much related to the topic of our presentation, because the moment machines will start to generate this type of fake news, we will be in trouble. We will be in trouble because we tend to believe what we read, what we see. Notice this piece of news, not at all related to artificial intelligence, because it is quite an old piece of news, where the Twitter account of US news agencies was hacked. It said that there was that the White House had been hacked, and it was actually fake, but it had an impact on society. So when we give a second thought to it and I say, will we end up understanding each other? Imagine a corporate network. Imagine that they have solutions in place using artificial intelligence. Imagine that we have network traffic, and we can train our AI to detect malicious and not malicious traffic based on supervised algorithms. This is a real case with some of my colleagues did a proof of concept. So they learned or taught the AI to classify the traffic. Then they moved on to the testing phase, and they say, oh, there is an anomaly in the traffic. So there's a high likeliness for it to be anomalous. And then there is another element, which is we can also find on the internet, which is fish AI. Also based on an algorithm, phishing sites and non-phishing sites are classified. Artificial intelligence detects phishing or not. All right, so let us start now. I'd like to share you some basic concepts about machine learning. Well, they may not be basic to some of you, because I know that many of you are actual experts in artificial intelligence and machine learning. I would like to take this opportunity to share with you the techniques that we have used to generate the model and the attacks. But let us give you some background now. So first of all, what is machine learning about? It is a branch of artificial intelligence that we can infer patterns within data once these data are fed. So it started off back in the 80s, and then it evolved into another branch, which is deep learning. So the good thing about machine learning is that it helps us generate models, and models are just mathematical representations of the processes that are taking place in the real world. What is actually valuable here is that we are able to make predictions based on the data that have been input. So this paradigm is both supervised and non-supervised. Actually, generating a machine learning model requires giving training data to an algorithm. And here we would like to talk about another element, another concept. What do we mean by machine learning algorithm? Well, all of you present here know what algorithm is about. Because of the training that you have, it's a number of steps in a specific order for a specific purpose. We will be defining it as the set of steps that are given to a model so that the model can make the calculations and execute the function that we wanted to make for us. Then, within machine learning, we are moving about in different paradigms. So learning paradigms here are the inductive one and the enhanced one. Here we have the supervised and non-supervised learning, and then the semi-supervised, which is a combination of the other two. We will be focusing on supervised and non-supervised and generative models that have been used to generate attacks based on the non-supervised learning. And now I'd like to mention the enhanced learning. This is the learning where people work in an environment and they get a reward in exchange, and then through trial and error they find the necessary sequence of steps to maximize that learning, to enhance that learning. Now going into supervised learning, this is quite a self-explanatory graph. We have input data for the algorithm, then we have a number of labels. Because you have taken some time to label the samples, you just feed the algorithm with it. The algorithm learns from it to generate a predictive model, and once you have testing samples that your algorithm has never ever seen, then you get a label. Label may be either classifications or other type of data, infinite data, numeric data. And then here, now in non-supervised learning, the approach is quite similar, yet this time we do not have any labels. This, on the one hand, makes things easier because we may get quite a lot of data. We may have quite a lot of data, but we don't have to label them. Often this type of not supervised learning, it focuses on clustering and grouping, and it is of an exploratory nature, aimed at discovering characteristics in the data that we couldn't do otherwise. For instance, we are talking about classification of images, processing of natural language, etc. Another basic example or concept that we should understand, should know to understand fake news attack, neuronal networks. Using a mathematical model, mimicking a set of neurons, they are stacked in different layers, and this allows us to infer data. These neural networks, the most basic ones, are it's one network with an entry layer, an output layer, or input layer, an output layer. In this case, there are two layers, but number of nodes is variable, and each of these nodes is a representation, mathematical representation of what it is considered to be a neuron. So each of the inputs are escalated, and then the activation function is implemented, and then there is an output, a resulting output. So the behavior of a neural network is defined by the architecture. Our architecture is characterized by the number of neurons making up that network, the depth as well as the number of layers, and the nature of the connections between these neurons. So the main architectures that are often used in deep learning, in this case, is a set of algorithms that can model the traction of data based on these architectures of deep networks, often talking about deep neural networks, conventional neural networks, recurrent neural networks that perform better or worse in some fields. Often the convolutionals are better for artificial vision, whereas the recurrent ones are used for language processing. So here we see a convolutional neural network. This is the typical example, which is often used to show a deep network for supervision. So if we get to have a set of images with cars, trucks, aircrafts, if they are labeled, we just give that to a convolutional network. After training it, we can infer whether the image that has been input is that of a car, a truck, and aircraft. This is supervised learning, and these type of architectures are also useful for non-supervised learning. Based on all that, well, we've been trying to summarize machine learning and deep learning in 5 minutes, which is a bit ambitious, so to speak. We move on into generative models. Generative models fall within the non-supervised learning paradigm, and the main purpose of it is finding patterns in the data that would enable us to generate new samples from a known probability distribution. So here we have the variational autoencoders and generative adversarial networks, and I'm sure that you are aware of these two approaches. First of all, autoencoders. What are they about? Well, this is very simple. We have, well, there is one limitation here. There is a layer, lower size of the input and output layer, and the mission of this architecture is reproducing input data in the best possible manner. And this is the way the algorithm is being trained to come up with a model that first allows you to compress the images and then to decompress them. So we have images of Pablo, one of the videos that we made for face swapping, and then we have the reconstructed image. So, well, there is a bit of a distortion here. So here we have these first parts where information is coded, and often these type of systems, when we work with images, we need convolutional networks to have a latent space to the Z layer, that is to say, a base vector that would allow us to narrow down the characteristics of the image. And why do we want to narrow down these characteristics? Well, to capture meaningful variation in the changes in the input data. Then we have the decoder, which is the top part. When we have that latent vector, we just want to reconstruct our image, our input data. The characteristics here are very simple. Often they have the same architecture, but inverted than that of the encoder. So let us assume that our model is already trained. The autoencoder architecture is already there that allow us to reconstruct images. If we wanted to generate new images from our Z space, from our latent sector, we will have to make a sampling using normal distribution, and then we will obtain faces of Pablo and scene faces of Pablo. This is known as variational autoencoder. Now I'll also try to summarize what generative adversarial network is about. This is a set of two neural networks that are competing. We have two gamers, a discriminator and a generator. The generator can be assimilated to decoder and autoencoder. From a random noise, a fake image is generated. Discriminator is a classifier, mainly gives you either a 0 or a 1. 0 would be real Pablo, and takes real images of Pablo, compares them against the image that has been given by the generator, and it tells you the level of match. and then tries to deceive the generator. How do you train GANs? Well, you generate samples that you give to the discriminator. The discriminator sees the likeliness for that image to be true or false. And often these type of architectures are trained to demask the generator, maximizing the likeliness for the discriminator to be wrong. So we also see how close G has been, how close it was to deceit. So it takes some time to train this type of algorithms with standard models. So the model may not converge. It is difficult to choose the right architecture as well as the right parameters. So therefore you have to choose wisely. Sometimes playing with these parameters or working with these parameters could be a bit tedious. The generator may also become stagnant or blocked, and then the samples may not be vibrant. Well, that can be corrected through mathematical techniques, but you can also try it through the technique of making the discriminator able to tell the generator how close it was from deceiving it, or perhaps the generator becomes like really smart, very good over a short period of time, and that will also have an impact on the actual learning. And now let us play a bit. After theory, let us see what we did. And now thinking about fraud to CEO applicability in the offensive side, then, well, later on we'll also tell you how to detect this type of deceit. So this is something that we can all use. We can also use cloud, and at the end of the day, resources are available at an affordable price. So Pablo has become a comedian. So we did a face swapping with Autoencoder. On the screen, you see the code of the library where you can get it. Okay, let's show it to you. Do you know him? I'm here to talk about the limits of humor. I was born in 1981. At the end of the 80s, early 90s, there were no limits in humor. You could tell jokes about the prime minister, terrorist groups, about the royal family. You could also tell jokes about the whole royal family. At that time, jokes were told about the mother of the king at that time. All right. Okay, what we have just seen, it's me being the comedian. So the face fits in well, same as the color of the skin. And now we have Enrique as a coach, okay? So the attack is not me becoming a comedian, well, which could be it as well, but us getting a politician of a person of influence and showing the real face of the person, but changing the gestures of this person. Okay, we'll show you that later. That will be the actual attack. And let us see what happens, how autoencoders work step by step. Let us take a look at this case, okay, Enrique as a coach. Well, this one did not come out as well, or that well.
They are real. Do you want other real? I'll give you a couple more real.
Yeah, the problem here is with his eye.
The worst position of Manchester City in the Premier League was 4th. In the last 7 years, Manchester City was champion twice, and if you want to say 3 times, because they will be in one more week, 2, 3, or 4, and they were second twice. That's everything.
Okay, so you can see
¿Cómo se hace esto? Lo primero
the eye
es la extracción de los frames de los vídeos, ¿no? Por un
doesn't
lado
look very
tenemos un vídeo de estilo
good.
que es
So we have
Mourinho, poner la cara
target
de Enrique,
video.
vídeo Mourinho,
So we
por lo cual
want to show
extraemos
Enrique's
los frames,
face,
luego
then we take out the
detectamos
frames, and
su
then
marco facial.
we detect
Y
the
vamos viendo
facial
cómo podemos recortar
framework.
esa cara de Mourinho en cada frame.
And
Eso
then
lo
we
hace
kind
se
of
hace todo en ese entrenamiento.
fit in the
Luego
face of
tenemos el vídeo
Mourinho
fuente,
with
que al final es
in each of the
Enrique.
frames.
Grabamos
Then
a
we
Enrique con
have
varios movimientos, fijaros.
we record some of the movements of Enrique.
Ahí, con varias formas, intentamos, lo ideal sería condiciones similares al vídeo. En este caso no lo es.
Ideally,
Condiciones similares al vídeo, eliminación
you would like to have the same
orientación del
conditions
rostro
in the
para que luego
video, the
sea más
lighting,
sencillo
and
poner ese
face.
la extracción de 2 minutos aproximadamente son 2.924 caras de Enrique.
So in 2 minutes, we extract like nearly 30,000 different faces for Enrique. Then we train the algorithm. We have the theory that Enrique had just told you, the encoder. When we input real images, then we reduce the sizing, we capture the characteristics of the real image, and then decoder help us reconstruct the image from the elements here on the vector base. So here we have the characteristics that help us reconstruct the image. The more trained the algorithm is, the better will be the output. So we have Enrique's side, Mourinho's side, and decoder. Encoder is essential, is key, because if the encoder couldn't use both sides or both faces, we couldn't really cross the two faces. But if we do it in this fashion, this is what we will get. So we have Enrique's original images, then these are the reconstructed images, then original image of Mourinho, reconstructed images of Mourinho, and now here in orange we have Mourinho facial traits mixed with Enrique's face, okay, and this is the mixed. Okay, this is a time lapse of 1 day. Okay, becomes sharper and sharper the more you train it.
Vale, y esto realmente funciona así. Si nosotros tenemos
This is the way it works. We have the original image, the trend vector base, then decoder of Mourinho, and then this will return the traits of Mourinho with Enrique's face. Here, we can make Mourinho behave as Enrique would like him to behave, and then that would change it completely. Well, but we will not be doing that. So Enrique may record the video of himself and then apply it over Mourinho's video. So what the big problem here would be me recording myself doing something which is really crazy, and then I would just swap my face and put instead the face of a person that I really want to attack. So we really wanted to investigate how we could work with GANs. And this also allowed us to see how the CEO fraud works. We wanted to use this generative model, and then before a webcam, we could generate the face of a person that we want to impersonate or to swap, so that the person would end up doing whatever you would like to that person to do for you. So we use the face-to-face demo, and we also use this library, which is quite interesting, the pics-to-pics TensorFlow. So you get an original video of a person, the person you want to impersonate. You have all the frames, then you train the GAN, and once your GAN is trained, then you generate fake images.
Now we go to our CDO, which is a YouTube video with a white background, because we also saw that with colored background we had many problems. Chema never moves, it's always the same plane, the face hardly moves, and it is easy to draw the facial landmarks. So this is done with this library.
Puntos bien conocidos del rostro de la persona. De este vídeo de Chema extraímos 728 frames.
We draw 728 frames to train our general model. So then we proceeded to train the model. It's a very simple, it's very well explained. So we were training our model. Once we had it trained, and we saw that the generation of images did not improve, we decided to test the model. The first thing was to diminish the trained model. It was 1 gigabyte per file, so we had to reduce the trained model so that the webcam could capture the image, take the facial landmark, so we could use the image as an input. We reduce the model because we don't want multiple files and we don't need the metadata of the TensorFlow. We just want the weight of our architecture. That's how we started testing. Now here we will give you a quick demo so you can see how it works.
Muy rápido. ¿Dónde está el cacharro? ¿El HDMI? Aquí. Listo. Gracias. Pues lo que vamos a hacer es, nos vamos a meter en el entorno que tenemos creado en Python. ¿Qué quieres poner tú, Pablo?
Sí, igual sacamos a alguien del público. ¿Alguien del público quiere convertirse en Chema?
Okay. Anyone wants to make this into 10? Okay, I'll do it now.
Pues nunca hemos probado con gafas, pero vamos.
Quítatelas.
Bueno, primero testamos nosotros si quieres.
First we test so that people can see.
Adelante.
Lo que nunca lo hemos probado está en oscuro, ¿no? A oscuras.
Ahí va. Es muy importante colocarse a una distancia.
It's very important to place yourself at a similar distance to that of Chema in the original video.
Ahí, más o menos. Y lo bueno es que esto te
The good thing is copy the facial features.
no es perfecto.
It's not perfect, but
Que no hay trampa ni cartón.
there's no tricks here. This is valid for anyone who would get in front of this webcam. Here, the teeth are missing because Chema never shows his teeth in the video. Ask for a raise.
Di que sí. Vale. Muchas gracias.
Okay, thank you very much. This is a model trained for only 3 days, and in fact we had a model with a resolution of 1024. We would have liked to increase it more, but we couldn't because we needed 8 gigabyte memory, and this computer only has 4.
El audio está aquí.
El audio está ahí. Oh, bueno. Mute.
A sufrir un poco ahora. Ahí.
Listo.
Hacemos lo de la Fórmula 1 aquí cambiando ordenadores, ¿eh? Bueno.
Se ve. Vale, perfecto. Bueno, pues.
Vale. Pues.
Dale.
¿Sí?
Adelante.
Vamos a ver ahora. Claro, cuando hemos visto a Agus ahí convertirse en Chema.
When we saw this guy becoming Chema, there was a problem with the eyes apparently. Oh, and the voice actually. which is different. So we have to see what AI can we use to generate audio. Do you recognize this voice now? No audio, apparently.
And I'm very busy.
A ver.
Are you available to handle an international payment of $15,000 this morning? Please find a way around it. I'm currently in Las Vegas and I'm very busy. Use this IBAN number for the account where the money has to be sent. Take note of it. ES 912100418450200051332. Insert to send me the slip once it's done and don't tell anyone. This transaction has to be...
Vale. La estafa al CEO se nos convierte en la estafa al CDO.
So this becomes a CDO swindle, because both the image and the audio we wanted to match. We have a model that is able to generate this image of Chema, actual, quite real image, as Enrique was saying. With more time and more computing power, it would have been better. Then we were concerned about the audio. We were trying to see what we could do with it. So Microsoft has an API that we can use, a neural network where we can train with the audio of an individual. We can download videos from the internet. When people speak, they improve their way of speaking. In Spanish, this is not yet available. If we put this voice in Spanish, we would have someone. It would be kind of weird. It would be a Spanglish sort of thing. So what we did was this. We used this service to train the network, downloading audios from YouTube in which Chema ends up speaking English. Then we divided it in 30-second slots. So the recommendation was a bit more because the tone was a bit kind of canned. And with more audio, with a better audio source, it would have looked more natural. Also, we had to transcribe what Chema was saying in the video, transcribe that to text. For that, we use a speech-to-text Google Cloud, an API. And then we uploaded audios and transcriptions to this service we started to train, and 8 hours later, the result was okay. Then we said it is true that still we need this to counterattacks. So then, where is Lucas? Please raise your hand, Lucas. Lucas helped us. He was working, but he helped us with the audio. He said, let's make this a bit more real, because it is important, apart from the voice and the vibration and all that. He added some noise, so we'll see some of the results. Here we have Luis and someone's faking Chema, and he says, I can't right now, I will give you a call, this text message says. So, are you available, Luis? Luis answers, and he says yes. So here's the call.
Hi Luis, are you available to handle an international payment of $15,000 this morning? Please find the way around it. I'm currently in Las Vegas and I'm very busy. Use this IBAN number for the account where the money has to be sent. Take note of it. ES 912100418450200051332. Insert to send me the slip once it's done and don't tell anyone. and this transaction has to be supervised only by you. Thanks.
Bueno, y final. Vale, pues...
Okay, that's the result.
Lo que quisimos también, yo le decía a Enrique, esto hay que probarlo con alguien.
I told Enrique that we had to test this with someone to see how credible the audio can be and the sound and the image. So then we started making tests. We wanted to diminish the metallic, the canned sound. So we started to see that people could actually go for it, could actually buy it. So then we're talking about email, and here we have a video which is very real audio, and someone is substituting the identity of someone else. As we've seen, it's quite easy to generate these fake personalities. You don't need to have a physical test. You can use cloud services, which can cost between 300 and 1,000 euros, depends on the gigabytes. We could go up to 3,200 euros in the cloud, but it's very simple to generate these contents to deceive people. Now, with 3 people working for a few days, we were able to do this. Imagine what we can do with a dedicated team with substantial resources. Another source of fake news, one of the first to appear, was the text fake news to confuse people. We have an overexposure to information in social media and all sorts of digital media, and we tend to believe absolutely everything that is written because we read information from sites in which we trust and with whom we identify. So this makes it easier to disseminate fake news. So 5% may believe it, so then you can see it as a success. There are a number of resources nowadays that allow you to determine whether a news is fake or not. We're talking about supervised learning. So you have to take news to determine whether false or true, whether 1 and 0 with deep learning and machine learning algorithms for natural language processing. So you can obtain a model that is submitted to these procedures. It will give you a result, fake or true. This is a well-known procedure, and there are a number of resources and services to analyze the truthfulness of the news that you read. So if you want to protect yourself from that content, you can use many services. We found a couple which are highly intuitive. So you could see whether the news was fake or legit, if it was satirical or cynical. So then we have the fake news detector, which is called Robinho, I believe he said, and then we had a service that is called Fake Box. You just send it the URL of the news. It'll make a quick analysis and return you a probability of that news being fake. If someone you want to take a look, we will have a small demo later on about how you can use IA to the service of genuine news and biometric patterns and videos. However, there are very few news that are not supported by audiovisual material, that are purely text. So here we come back to fake news and fake videos, which are becoming more sophisticated, and it's very difficult to see whether the content that you view is legitimate. There's a group from the MIT that is looking for biometric pattern in these videos that allows you to determine whether the video is false or not. We found an interesting publication based on the video by Jennifer Lawrence, in which they analyzed the lack of or the excess of blinking as a sample that you are that you're watching a fake video, in addition to the color histograms and the contour of the face to determine whether the face has been overlapped or automated. This person here we made a face swapping with Nicolas Cage, and in frame 75 Nicolas Cage doesn't blink, but in the original he does. So we make use of recurring convoluted networks to detect false videos, and this includes the probability of the eye being closed or not. So this allowed us to determine with high precision whether the video was false or not. As we couldn't reproduce this POC that was quite interesting, we said, okay, as we have small knowledge of machine learning, let us build a classifier making use of typical features that we can draw from a video. In this case, is the duration of the blinking and the blink rate. All those biometric parameters are tabled. There are many publications on this. People from different sex and from different condition and different characteristics blink at various rates. So on that basis, they say you can say whether you are watching a fake video or not. If you're reading, you blink maybe once every 5 seconds, but if you're talking to someone, you blink much more frequently. So we try to find these exceptions, duration and number and minimum separation between blinkings. So here we have one of the papers collecting all this data on blinking rates. So what we did was create a Gaussian classifier on the basis of blinking speed. So we established a normal distribution, and we tested our videos against that model. So it works very well. The idea is simple. It's improvable, of course. Many more characteristics can be included, but the basic test is that we have, for instance, that the video in the case of showing Pablo's face, the actual videos of Miguel and Pablo were labeled as true videos, whereas the face swapping was went upward and was rated as false. And the same as the one of Jennifer Lawrence and Jennifer Lopez. All of these videos were tested, and one was catalogued as true, but then the face swapping changed the thing completely. So both videos had an excess of blinking vis-a-vis the original video. This is just a simple example of how to protect ourselves against this type of attacks. But as the passage of time, these models improve, and at an exponential rate, so it'll be complicated to differentiate one from another. So, as regards conclusions, well, to finish, we have just 1 minute, I think, 1 minute left. The first conclusion is that it becomes difficult to differentiate what is real and what is not. the first thing we have to think about is how we can protect ourselves from what is real and what is not real, because all the individual freedoms that we have constructed throughout our history will be worthless. And the second conclusion is that cheating people is cheap. It's not expensive in this domain, because we use a device that anyone can buy, very low training learning curve, 2-3 days, custom voice devices, and this is available to anyone, and it can be used for good things or bad things. For us, one conclusion is that the AA and cybersecurity will go hand in hand towards the future, and that the limits of IA have not been set, and cybersecurity will be strengthened as well as attacked by artificial intelligence. So we have to be aware of this and take it into account. So knowledge and awareness are the pillars on which we will again support ourselves to protect ourselves. So awareness and knowledge of all by the whole society is essential. So any questions or comments will be welcome.
Bestial. O sea, es verdad, a muy bajo coste, muy pocos días.
Very low cost, very few days. Oh my God, I was sending this to my work colleagues. This is the CEO swindle. So, for questions, you have to go where the mics are. I have one, actually. Just as you made a training model to follow the interest points of the face and overlap, you make a second post-production state to clean all the details that make the video different. And you can do that professionally, and the video ends up perfect. There's nobody who can differentiate anything. That is the first example shown by Pablo of Obama. That is a very intelligent approach. They take his original video and they reproduce the speech with generative movement of his lips. So he ends up saying something else than what he originally said. So, any question, any microphone that wants to speak up? This is good for hybrid war attacks. I'll invent a scenario if I can get into a electric generator and it causes glitches in one area. I record it. I get a president of a CEO of a utility. I hack a news. I invent it and say that we have a suspected nuclear attack in this area, and you cause glitches in the city and you release these news. Well, information is power, and what we see is what we believe. So we need to have a critical thought and put into doubt, into question, whether what we're seeing is real. We have to invent a form to differentiate what is real and what is bogus. Yeah, impressive. I have a question. Where are you? At the top. How can you apply these IA intelligence and deep learning for classifying events? I have a system that collects events from many servers, and I would like to be told through these techniques when an event responds to a malicious event. And I have, as training, I have the usual, the routine, which is not malicious. So when we're talking about anomalies, we had a similar case. It was a supervised algorithm to tell them which are normal events in a system and which are non-usual events, and label them as such. So then the system learns, so when you are in production, you will have this classification of events. This has been classified, in which this is the case for AI. The thing is, I have all normal events. I only have abnormal events when I'm attacked. Well, you have to generate mimic attacks. Well, it's a very case with the anomalies. Thank you very much.
Muchísimas gracias, espectacular, ¿eh?
Thank you. That was great presentation. Thank you.